This is your first math tutorial in the series. It's on the chapter compound interest, and it's basically an advanced version of what you've learned before. That's simple interest. You know the difference between the two. That's very important. Simple interest, which is SI. You've been doing that throughout middle school, and you should know the formula. It's P R T upon 100, where P is principal, R is of course a rate. It's usually per annum unless it's specified otherwise. And T is the time period. The difference between this and compound interest, which is CI, is basically that in compound interest, your P changes with every T. It means that supposing your time period is 2 years and the interest is compounded annually, that means that the interest from the first year will get added to the principal, and that will become the principal for the second year. So I for year 1 plus the original principal becomes your principal for the second year. So it's obvious that if, say, your time is more than a year, CI will always be more than SI. Now, the formula for calculating compound interest, it goes something like this. A is equal to P times 1 plus R upon 100, and the whole thing to the power n. Now, A over here is very important. It's not CI, it is the amount. An amount is equal to the principal along with the compound interest. P is again principal, 1 plus R is rate, and N, again you should note that this is not equal to the time. It's actually equal to the number of terms. What that means is that suppose your rate is given not per annum but semi-annually or quarterly. It means that, say, your rate is semi-annually. In 1 year the number of terms will be 2, not 1, because the number of times that your interest is compounded is not 1 but it's 2, because a year is then divided into 2. So this is the main difference between this time and this time. Before I move on to the next section in this chapter, I'm just going to recap some of the really important points which you need to remember over here. The biggest mistake that people make, I've made it hundreds of times, is this. Over here, it is not equal to the time. You need to keep that in mind whenever the question says semi-annually, quarterly, so just keep that in mind. And also here, many people mistake this amount and they carelessly mistake it for compound interest, whereas it's actually the amount. So if you have to find the compound interest, don't forget to minus this. And if you want to put it in that form, you can write it like CI is equal to P into 1 plus R by 100 to the power n, and just add a minus 1. And the P is into this whole square bracket. So just remember that. The next part of this chapter basically deals with the problems where you're given the rate but it's not in per annum, but it's in either semi-annually or quarterly. Semi-annually is also written as half-yearly. So there are two things you need to remember over here, and people often go wrong over here, so you should pay special attention to this. Um, Whenever it is half-yearly, the rate becomes half as well. This is for half yearly. I'm just going to make the font smaller. When it's quarterly, that is 1 by 4, then the rate, which is given to you originally, becomes r upon 4. At the same time, the n, as I said in the earlier section, you have to multiply the n by 2. If the time is given as a year and it's semi-annually, that means there'll be 2 terms. So you just multiply that 1 into 2, that's 2. And similarly over here, it becomes n into 4. And often they'll give you these questions expecting you not to know this, but it's one of the basic things, so you really should. Okay, that's all you need to know when the data is given in form of numbers. Often you'll be given the same data, but in the form of a word problem. And that topic is called growth and depreciation. I'm just gonna write G and D, I don't have space. Oops. Okay. Basically, growth is obviously something growing, so something increases over a time period. So if you take that formula, the compound interest formula, A is equal to P 1 plus R by 100 to the power n, you can see that amount is what you get at the end, P is what you start with, R is the rate of growth, and n is the time period of the number of terms. So if something is growing, it means that at first its value is less, and that is the initial value, which is P in this case. Over time, it gets multiplied by all this and the rate as well. And eventually, after this time, it becomes this. So it grows into this. Depreciation is when something's value decreases. So at first, it's higher, and then slowly it decreases. So in that case, the final one will be this one. And the initial one will again be this. But the only difference here is that when you're talking about depreciation, the final will be lower than the initial, and in growth, it'll be higher than the initial. And this over here, it says 1 plus R by 100. Now, when something is growing positively, that is growth. When something is growing negatively, it's depreciation. So basically, depreciation is negative R. So you'll be given, say, 5% or 10%, but you will actually write it in the formula as 1 plus minus R upon 100, which obviously you can just write directly. Just write this a minus. So for growth, you always add a plus over here. For depreciation, a minus. Okay, that's it for this video. In the next video, it's going to be a small one, but we're going to tackle a few problems on these concepts.